This is Lab 3, Magnetic Field of a Bar Magnet. The purpose of this lab was to measure the distance dependence on the magnetic field due to a small bar magnet and compare your measurements to the distance dependence predicted by the equations for the on and off axis magnetic fields derived from the Biot-Savart law. The fundamental principles and equations used in this lab were B equals mu naught over 4 pi times Q V cross R over R, or magnitude of R squared, and then the magnetic dipole moment is equal to pi R squared times the current, or just area times the current. The summarized results from the lab were that the magnetic dipole moment equaled 1.7105, and the magnetic field proportional to distance was negative 3.2123. The assumptions we could make in this lab were that we assumed that the bar magnet acted as a magnetic dipole, the x-axis as defined by your magnometer at points along the width of your phone, the y-axis points along its height, and the z-axis points out of the screen. And the magnitude of the magnetic field due to the bar magnet is proportional to some constant times some power of the distance. The system for this experiment was the magnet, the meter stick, and tape, while the surroundings was everything else. The setup for this lab was set up the phone and magnet so that a net magnetic field with the earth and magnet was created. Locate the magnometer of phone by sliding it perpendicularly along meter stick. Found several different magnetic field values by moving phone at various distances. Observations from this lab were that when the magnometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnometer moves closer to the magnet, the measured x component of the magnetic field increases, and the position of the phone matters in terms of accurate readings of the magnetic field. Here is the overall data collected from the lab, from the Excel sheet. Basically, that summarized was that the distance dependence equation was y equals negative 3.2123x minus 14.888, with n equaling that negative 3.2123. And the natural log of k was the negative 14.888. Therefore, k equals 3.421 e to the negative 7. Finding the magnetic dipole, we used the Biot-Savart law to find magnetic dipole, resulting in that mu equals 1.7105 value. Here is the glow script code I used to create my model, which is shown on the right. And the discussion questions for this lab, the differences between the model we had in the theoretical model that the B perpendicular, or B perp 1 really, equaled negative 2.13812 e to the negative 5 in the x direction, or in the positive x direction. And the experimental model Bx of t equaled 3.9533 e to the negative 5. So potential errors was that the magnometer might not have been centered with the Earth's axis, skewing results from the experiment. Locations of the magnometer on the phone might have been off. So what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The results would have been less accurate and skewed towards Earth's magnetic field. What if you were to stick two identical magnets together end to end and run the experiment again? How would you expect your measurements to differ? The direction would remain the same and the magnetic field would double. Thanks for watching.